Right, back now. If anybody is there, I don't think anybody is looking at it, but yeah, I'll just yeah, wait a few minutes for people to get on, and then we'll see what's what. Obviously, if you are here, obviously you can put a message in the chat. There's quite a big delay because my internet's not the best, so yeah, so there's a little bit of a delay. There's a little bit of background noise as well, so if it gets too much, let me know. It says 2 people watching. I don't know if that's just me and my 2 devices, because I am watching it myself, so I can see the delay and things like that. But yeah, so put something in the chat if you're here. But yeah, that's it really. Right, so Amelia, you're here. Nice to see you. It might just be me and you. Obviously, I'm going to leave the chat on, provided I can't imagine it's going to get busy. If it does get busy and people start getting stupid, then I might have to turn it off. But I was just going to. I've got this. I've got my tablet set up, and I've got this the practice paper, which you should have access to, Amelia. Everyone should have access to it. It's in Teams, but I can go through this if you want. Or what I can do is, if you get this up, if you want to pick particular questions you want me to go over how to do, that may be better. If not, I'm happy just to go through the whole paper. But if it's just you and me, Amelia, I'm absolutely happy just to do what you want me to do. We've got a bit of time obviously on Monday as well, because Monday being the afternoon exam, I have a lesson period 1 from 9 until 10, and then I've literally got nothing for the rest of the day. So after 1 o'clock, like, I'm done. So I can literally do anything you want me to do on Monday as well. Yeah, so absolutely happy to do what you want me to do. If you just want to put something in the chat. If not, I will presume you want to start with this one. Now I'm just trying to see if I can get the chat to pop out. Just give me a second. But nope, don't want that. Because you can do something where you can see the do I want that? Nope. So just bear with me whilst I'm just doing this anyway, because I'm just looking for my that. Nope, don't want that one. Shut up. Chat. And then hopefully. Okay, whatever. So you should hopefully be able to see. It's just for me, just because I can't really see my chat screen. I can only see this on the left, so on the right. Sorry, so yep. So I mean, there'll be a little bit of delay till I actually start. So by all means, if you want to do the question and see what I answer with, it's up to you. But I'm just gonna leave that chat on there so I can see it. Obviously, if it gets a bit bigger, it gets a bit silly, then we'll do whatever. It's not too much of a delay. I'm listening to myself a little bit. But hopefully you see us alright, so I'll just see how fast this appears on the screen. I'm just clicking this corner. Hopefully we can see that. Oh, does it keep appearing above? That's interesting, but I don't think I need that. So if I do that, and then that pops up, so we'll move that to the other side. As you can imagine, I've not really done this before, so there we go. And then if I do that, does that keep it on? No, it doesn't. Oh, that's annoying. I can still sort of see it if I just if I do this and minimise this. And then that. Right, I think I can see everything now. Yep, so first question being, what is utility software? So hopefully we notice things like your defragmenter, it's your antivirus, disk checker, all those kind of things. So they are specialised piece of software. So special software, which usually gets you a mark for that. special software with a single purpose. So defragmenter does one thing. Purpose. And then we always say, obviously that would get you 2 marks anyway, but to maintain the PC, that kind of thing is what we're looking for. So that's like that, and then so hopefully that should be like a nice, relatively easy one. Give one advantage of using RAM as storage in this way. So a company releases a utility called utility software. It creates virtual storage drive from an area of the computer's RAM. So why would we do that? Well, RAM is faster than secondary storage, so RAM faster. Excuse my handwriting as well. Secondary storage, and then the utility periodically copies what's in the RAM drive to secondary storage, such as a hard disk. Why does it do that? So obviously in this situation, I can't draw on this side, can I? Situation, you've got obviously, like, imagine that's your RAM there, where we start running current running programs. But of course, we know that RAM is volatile. RAM, we forget things once we turn it off, so it's not actually going to remember anything. So essentially, it's going to snapshot this once you're done with it, and go and stick it into your There's a picture of a hard drive there. So RAM is volatile. I don't think you need any more than that really. So RAM's volatile, and then secondary storage required to save long term. You could also, what if the power goes off? What if the computer breaks? So in case power goes off or something like that. So that'd be those marks there. I'm hoping that that's nice and easy. Obviously, just feedback in the chat if you have any questions or anything you want to go over or explain or anything like that. I'm just going to move my keyboard and mouse a little bit because I'm not going to be using them, and it's nice to actually be able to put rest my hand when I'm not carrying this tablet. 1 sec. Sorry, doing 2 things at once. Give me 1 sec. So this one is the practice paper. If you don't have it, I can put it in Teams for you. Just put it in the chat on the left, on my left, and I'll. So I just need to go do something for my wife real quick. False alarm, we're good. If you manage to get it, Amelia, it should be in the past papers folder if it's there. So moving on to the next one. If you don't have it, I can Teams you it. I'm sure. Sure, we can't send files. I suppose it's probably a bit dodgy if you could, but you can't really send files on YouTube. So where am I looking now? I mean, I actually need to be really careful that this doesn't appear on the main screen too quickly anyway, because that could be bad. It's only the monitors, that's alright. So if you need it, Amelia, I can just send you that now because I've got you with my messages. Upload from device, downloads, and it's this one, I think. There you go, you've got that now. And is it that one? Yeah, cool, sorted. So you should have that. I've sent you on Teams, Amelia. Right, so next question once you get that open is it is important that enough RAM is left for the operator system to use. How can we deal with, how can we sort out what's the technique to overcome when we don't have enough RAM? So obviously we should know that we use virtual memory. So virtual memory, and what does this actually mean? So virtual memory would on its own wouldn't give you a mark, so we need to explain what actually happens. So we'd say our RAM is divided, split up, whatever, into pages, and then we then move those pages to virtual memory on secondary storage, and then when page is needed again, move back to RAM. So that's pretty much it really. So you're not going to get a mark for just saying virtual memory, but you would get a mark if I just change my pen. So for splitting it into pages, your pages that aren't needed get moved to virtual memory, which is there. Then there's another mark for explaining that it's on secondary storage, and then once you're done, put them back into RAM. So that's what we do for that one. Obviously I'll leave it on the screen a little bit in case you want to look at it. I think it is just going to be me and you, Amelia, at this point. I've just put it into I'm hoping I've put it into the Teams so other people come, but it might just be us. I'll also have a little look on my phone whilst you're looking at that. At least you can't say I don't do anything nice for you. Well, I've seen you've seen it, but I don't think anybody else. I mean, most people probably have a bit more of a life than you and me, Amelia. Probably doing something more fun, but oh well, they'll be laughing once you get a better grade. Right, so next one is modern computers tend to have magnetic or solid state hard drives. Discuss which would you recommend for a keen video games player to use on their desktop PC. So I don't think there's a right or wrong answer in that. I don't think you necessarily have to say one or the other, but you've got to think what are the factors that we need, like what we're going to look at. So you've always got, as you know, AO1, which is knowledge and understanding. We've got AO2, which is applying it to the brief, and then I don't have enough room there. AO3, which is the eval. Okay, so this is where you got to think. It's alright, Amelia, don't worry about it. I've got at least an hour for you, so it's fine. Plus, you know, I'll have it so it remains so people can watch it at least. But yeah, that's what I was saying. So we think what's the knowledge then? So our knowledge is going to be how they work. So magnetic. So obviously that uses platters. Platters / a spinning disc. I might change font colour. Solid state uses chip, sort of technically it's NAND gates, but that's fine. I think that's enough for this question. Then what are some things we know? We know that solid state is faster. That is more data stored per gigabyte, and it's cheaper. So our that chat's going to slightly cover that side, isn't it? I think I can make it a bit thinner. There we go. That's better. There we go. So it's cheaper as well per gigabyte, and then sort of less power. Depending on the, you can even argue as well that these solid state's quieter. If you think you're a keen video games player, it doesn't say streams, but you could stream, so that's something we probably could mention. Now applying that, how does it make sense? So you can store, if we say the blue is like magnetic, we can say you can store more games, which is obviously a good thing, which is decent. I'd argue longevity is a good thing. We don't worry about like we just say like portability for solid state and stuff. We don't really care about that because we're not going to move your desktop around. But we know solid state has a limited number of read and writes. But solid state has faster read and write speeds, which is obviously really good. That's something that we want because we don't want to be loading things and taking ages. And then obviously we can talk about the silent, you could say for streaming, or probably just so it's just quiet in general. Like if it's too loud for your headphones, it's quite annoying. And then you think, what's your decision going to be based on this? I mean, for me, I would probably go with solid state. So I'd probably say overall, I'd go with solid state, and then summarise that it's faster, it's still high storage, it still has high capacity, it's quieter, it's smaller, and I can't really think of anything. You could just say you're getting all of this, but it's more expensive. So you can say if you have a budget, you can still do some magnetic, but on the whole, it's probably better to go with solid state. That's how I'd sort of go about it. This is probably what I've written on the screen would probably be great for a plan, and then you do your sentences. That's what we're sort of looking for, really. But yep, so that's that. So then we've got a nice binary question. I mean, I presume you're fine with this one. So we've got 1, 1, 1, 1, 0, 0, 0, 0. Hit 1, 2, 4, 8, 16, 32, 64, 128. And I need to add those up. I'm not particularly fast at adding things up anywhere. I'm going to cheat and get my calculator up to speed up time. You don't have one, but you've got a bigger brain than me. So you've got your 128, 64 plus 32 plus 16. So it's 240. So we can just go 240. Hexadecimal, obviously we just split that bad boy up. Like that. That is clearly 15. So we've got F0. I don't know how well I can write on this, and this is really zoomed in. So I have to see. So this one is, we've got an AND, so that is 1 and 1 is 1, otherwise it's 0. None of these have 1 and 1, so it's going to be 0, 0, 0, 0. My pen's a bit big. So 8 zeros, so 1, 2, 3, 4, 5, 6, 7, 8 would be the answer for that one. This one is OR. So if any of these have a 1, that's going to be the result. It's going to be 1. All of these have a 1 in, so that's just going to be 1, 2, 3, 4, 5, 6, 7, 8. Because I'm just doing an OR. That was not very good to do. An OR on those. Obviously 1 and 0 equals 1, so it's going to be loads of 1s. So we're shifting this 2 places to the left, so it's going to be 1, 1, and then 2, 3, 4. So we've got 4 zeros after the first one. Obviously that's still only 6, so we keep our first 2 zeros. What does it do? Well, if you think that number there is 1, 2, 4 and 8, so that's 12. If we think we've got 1, 2, 4, 8, 16, 32, what we've done, we've multiplied that, haven't we, by 4. It's 12 plus 12 plus 12 plus 12. So we've times it by 4. So I'll probably write multiply, but I think star is absolutely fine. Minus 8 as a sign and magnitude number. So when it's sign and magnitude, it's just the same number as normal. So if we know that 8 is just 1, 0, 0, 0, 1, 2, 4, 8. That's that. If we make it 8-bit, 1, 2, 3, 4, 5, 6, 7, and then your MSB needs to be a 1, because in sign of magnitude 1 equals minus. So 2's complement, it's going to be exactly the same process, converting it to a negative number, but we're going to have 0, 0, 2, 3, 4, and then 1. So that's 8 as normal. Then what we're going to do is we're going to flip the numbers. So you can either flip them, so we keep these the same, so we go 0, 0, 0, 1, 1, 1, 1, 1, 3 zeros at the end. Or you can flip them all and add 1, doesn't really matter. So yep, so that's minus 8. And then this one is probably the hardest one, I think, for the whole thing, really. So I think for this one, I don't know if you can hear me, Amelia, if you want to have a go at this one, and then I'll go through it. I will just put this there just so you can see that properly. So I am still here, I'm just letting you have a go at that one. Just it'll take a little bit longer. I'm just going to sort some on the computer real fast. So. Right, hopefully you've roughly got some of that. So the first thing you've got to do anyway is we can sort of ignore all of them. We know that one is 2, 1 and 2. That's fine, that's that part is done. And we can look at our numbers now. So we've got 0, 1, 0, 1, 0, 0. We've got a decimal point here, 1, 2. So it goes there. 1, 1, 2, there. That's where that one goes. Our next number is a little bit awkward. I'm going to write it up here just to make life a little bit easier. But we've got 0, 1, 1, 0, 0, 0. But that one's decimal point is different. So that one's going to be there. So we just make sure that lines up correctly. So it'll be 0, 1. 0.1 and then zeros don't really matter, and we can just add a 0 there and there. Doesn't actually matter at this point. I'll just keep the bullet points in the right place, and then this one exactly the same. It's going to be bullet point there, 1, 2. So in front of that it's 1, 0, 0. So we've got 1, 0, 0, full stop. So 1, 0, 0, 0, 1, 0. I can put that there if I want, but it doesn't really matter. So that's my 3 numbers, all converted using the correct thing. I mean, I probably don't need this one, to be fair, but we'll ignore this one. So 0 plus 0 plus 0 is going to be 0. 0 plus 0 plus 1 is going to be 1. Sorry, I was looking at the chat at the same time. 1 plus 1 plus 0, so that's 2. So that's 0, 1 on the step. 2 again, so 0, 1 on the step. 0, 1 on the step. 0, 1 on the step. 1. So let's just. So it's a 6-bit mantissa for this one. So 1, 2, 3, 4, 5, 6. I think we could probably get away with for that one. I reckon. No, it's just double try to think now. Make sure I don't do anything wrong. So we've got 1, 0, 0, 0. 1, 0, 0, 0. Decimal point there. 0, 1, 0. That's right. And then I think. Our issue now is that we need to have it normalised, and that's where it gets a bit of a pain. If it's normalised, this number needs to start, because it's a positive number, it needs to start with 0, 1. And that's gonna be an issue. Because we need to keep this here. We've overflowed here, so technically the number, even though we've got this 1 here, that's an overflow. This is the actual number, right? And this is where it gets tricky, because this is the number that doesn't exist. It can't, even though we know it's there and it would be there, it doesn't exist. So what we actually need to do is get it so this stays the same but is normalised. Right, this is where it gets confusing. So this number normalised is going to be 0, 1, because that's what the number needs to be. Okay, and then the rest 2, 3, 4. Okay, so that's 1, 2, 3, 4, 5, 6 bits. So that's the correct number. That's what it should be, because we're ignoring this one now. But the decimal point is going to be over here, which would make the number wrong. To get it to be 0, 1 dot, how much does it need to move by? It needs to move this way. It needs to move that way by a lot. Alright, because essentially it needs to be 0, 1, 0. So to get that to look like this number again, there needs to be so we'll put it there 1. So 3 more zeros in front of it. So what do we need to do that? A lot. We need to move it. So it's 0, 1, it's there. 1, 2, 3, 4. So it needs to go 4 right. Now, for a negative, to go right, you need a negative exponent. So for that, it's going to be, I think 4 right is right. It's going to be, so if we're going 4 right, we need to have, is it 4? 1, 2. So I'm just trying to think to get it to look like that. It's on our number of 0, 1, 0, 0, 0. It's going to be there. 1, 2, 3, 4. I'm sure it'd be 4. So for that, it would be. Trying to think how I'd do it. can't be that. I don't think it would be that, because that would only move it by 1, which wouldn't be right if our number's that. Does it make sense what I'm going through, Amelia? Like, does it make sense what I'm trying to do? So I'm trying to get it so I can keep this number of 0, 1 and 4 zeros, so that's right, that's the correct number, but I need to move it so it's 0, 1, 0, so those 3 need to go that way. So I need to move these 3 to that side. To do that, I need a negative mantissa, which I'm sure if I'm moving it to from there to be 1, 2, 3, 4, I'm sure it'd be 4. A negative 4 would be 0, 0, no, 0, 1, 0, 0. 2's complement that. It'd be 0, 0. It'd be that, it'd be minus 4. But they look, I'm just looking at the maths here now, it's saying it's either minus 7. But why would it be minus 7? No, so the actual mark scheme of this one is you calculate the first number as what I got. So the first 3 marks of this one I got correct. Add them together gets you 1, 0, 0, 0, 0, 1, 0, which we got. So that's 4 marks out of 6. And obviously you get marks for adding it up, so you get the carry bits. So I've got 5 out of 6 so far. I've got the normalised result. I'm just getting the. I've just checked now. I've got the number right. The mantissa's right. It's the exponent. Because I'm not, because the all the exponents are already, like, they're all positive. I've got to make it a negative number to make it move right, is what I'm trying to do now, if that makes sense. That's what I'm trying to do. But I was just at the mark scheme and they seem to think I need to do it that here. Just circle it. They're saying it should be that, which would be 1 to the right, but 1 to the right would move that to there, in which case it'd be 0, 0, 0.1, 0, 0, but it needs to be 0, 0.01. So it needs to be at least that, and that would move it to 0, 0, 0, 0, 0, 1. So it needs to be, that needs to be 4 zeros. So it needs to be negative 4, I think. And they're saying it's 1, 1, 1, 1, which would be obviously 1. So that's interesting. So I'm not sure why that's that, because I think it should be 4. I mean, getting 5 out of 6 is okay, but I'm annoyed that I can't really think why it would be that. It's be there. Oh, I think I know. So the number's there, and we just need to be 0.0. Yeah, I get it. I've been stupid. I've been a moron. So I'm trying to get it like this original number here. So I was trying to make it look like that, but it doesn't need to, because this is all trash anyway. So you've got, if I just rub this out. So my number is, it was that one at 0, 1, and then 4 zeros. That was it, wasn't it? Well, all I need it to be is something 0.01. So if I move it 1, it'll now become 0.01, which is what that was there, and that's it done. So that would be that. So it'd be, because that equals negative 1, which is 1 to the right. What I was trying to do was right, sort of, but I was trying to fully recreate the first number with all leading zeros, but then it's really not needed, it's unnecessary. So that makes more sense. I'll leave you a second for you to catch up and just see if you understand what I just did then, because I know it's a bit hard. Just realised my chair is really squeaky. Sorry about that. I didn't know. But that's like one of the harder ones when you get a negative one. Obviously, you can still get it, but you need to make sure if it's normalised, it's got to start with 0 1, so it's going to have to move the other way in this case. Right, next question. So below are extracts from the ASCII and EBCDIC character sets. You guys know what those are. So we're talking about, we've got these two character sets. So A is translated to 65, or capital A, and A on this one is 193. So it's saying what is the issue if we're texting each other or whatever, and we've got two different character sets. So obviously they would calculate a different number. So each PC would calculate a different value. I think that'd be fine. So the text wouldn't make sense. So it just, like, I'd send, hello. So I'd send 72, 69, 76. Well, in this one it'd be 200. So whatever 200, like exclamation marks things, it wouldn't make sense. Which, yeah, is stupid. So that's all. I think that's quite easy, that one. So this next one is writing something that converts these two numbers. So it looks a little bit scary, but we just need to look at what is the difference between these two values. So if I just grab this, so if we look on here, we've got 193 for A, take away 65, so there's 128 difference, which is fine. But we have got this blank bit here where there's a gap in these two places. I don't know if that's on purpose, if that's what this actual CDIC thing is, if it is actually like that, or if it's just made up on purpose to make it harder. It doesn't really matter. So all I'm doing is, if I'm converting from the EBCDIC value and returning the ASCII one, all I need to do is a bunch of if statements. So because I've got the EBC whatever value there, so I can just say if eb value. Now here I'm going to have to look on here because I can't go past here, so it needs to be between these two values. So is greater than or equal to 193, and we've got 201, so and less than or equal to 201. All I'm going to do is return that number, take away that difference, 128, and I'm just going to repeat that. So the next one, my next if statement, is going to be the same but between 209 and 217. I'm going to take away a difference from that. So if I do 209, so that's 4j, take away 74 is 135. So my next one is going to be EB val take away 135, and then calculate the next one, which is going to be where returning minus 143, and I'm just going to have an else, and I return minus 1. I'll just pop this across because it's the full thing on there, but I've just got the maxi of this one. As you see there, I've got this function. But if I'm honest with you, that's fairly easy. Just if statement checking and just subtracting. Really easy. So that's that one there. Next one, some assembly. I do a little bit of assembly. So what is the difference between, excuse me, STA and LDA? So STA stores the value of the accumulator into, I think, just memory is okay, whereas LDA takes from memory. Oh, that was a really terrible right memory, and loads it into the accumulator. So there's opposites there. Sorry, my headphones are like, I can't really hear my voice, but it's quite blurry. The audio for me isn't, but on the stream it is. So sorry about that. So if we're looking at this one here, what is the memory addressing we're using? So if we look at LDA1, it's loading 1. That's getting the. It's trying to sort of tricky because on the whole, LMC uses one type, and that is your immediate addressing, where you go to the memory location, like you go to 99 or whatever. But because what they've done is they've stored the values that you need for the whole program, like this. They're doing it on purpose. It's actually using direct, because direct does the actual, instead of looking at a memory location to find the value, it's just getting the value, because the value for 1 is 100. I think is what it's getting at there. I'm just checking something. No, I was just being stupid. I thought I was trying to trick you, but no. So LMC uses direct addressing, where we just point to the actual address. If we would have said load the actual number 5, it would be immediate, and then you don't really using direct or indexed on there. That was being stupid. Sorry. Kind of a pain, this next one, because you've got to actually trace something. So yeah, you've got to actually make a trace table. So I think we've done this one already, so I'm not going to go over it, but this one actually traces 10, 10, I think 3 times. I think that's the answer, because it just just loads that thing. I think we did this on the last lesson actually. Explain the buses and registers used. So when sub 1, so 1 is the address, so 1 would be stored in the memory address register. We then use the address bus to go to 1, and then technically the control bus is going to be used to say we're going to fetch something. So then the location of 1 is going to get moved to the data bus and the MDR, and then what we actually do in sub 1, so it's then going to do the maths, so then the ALU, and then it's going to store that result in the accumulator for that one. And then pipelining, what could we do with this one? So let's just say, what could we do? So we could probably, well, we know if we can fetch something as once been decoded, so we could fetch this one whilst we're decoding that one and executing that one. So think fetch, decode, and execute. That would be our pipelining for that one. And then pipeline is a factor that affects the CPU. What else? There's actually a GCSE question. Cache, clock speed, whatever it is. I've missed this one. So what's one issue that BRP you can pipeline if you've got a branch? So so you can't pipeline on a branch. So in this case, so until it's executed, because we're looking at the accumulator, so the wrong instruction would get loaded. This next question is mental in terms of, like, I know probably I shouldn't use the word mental, but it's like really difficult for what it is. It's like this sort of part of the paper, it's not a programming paper, but you've got quite a complex one there. And what I don't like is, like, in the exam, they use substring a lot. So I've done it in ChatGPT. Yeah, I've got ChatGPT up, but I tried ChatGPT actually, and the answer it gave me was real strange. I'll show you it. This is their answer for this question. Doing all this, match and stuff and make it look real nice, but obviously that's not going to help in the exam, because you can't just say, oh, I'm going to use a tag pattern dot match or whatever. So I did it like in the newbie teachery way. So basically the idea is that you put a string in like this, and it extracts the tags. So what you're looking for is, if you see a arrow thing, it's going to then get the next letters until it finds a closing one, and then put that into this data structure. I don't have that data structure, so I've just put it into an array. So essentially you're going to have a bunch of variables. So you're going to have well, this main one here, you're going to use a thing called like a start pointer or something. So when you find one of them, excuse me, we can set that to true and say, right, we found that. If it's true, if we find one of these, we'll set that back to false, and then we do a substring in between that and find out the difference. So does that make sense what I've said, Amelia? So I'm looking for the start. Once I get to the end, I can substring from the start to where I am and pull out. So this is mine. It might not be the most pretty, but leave that on there so you can see it. So you see, I put the string in there. I put a paragraph next, I nicked it off the internet. I've got, instead of a data structure, I have so instead of doing data structure a dot add, I do, so that would just be, data structure, maybe something like that, rather than adding to an array. So yep, so then I go through, I've got the start tag, which is my index, and then inside the tag as a boolean. So I go through my string, which is just this HTML string. So if the string I'm onto is that, and I'm not inside a tag, then that is going to be my starting point for my substring, and I'm going to say I'm inside it. Otherwise, if it's just a normal letter, and I am inside the tag, so if I am inside the tag, and I find that, then what I'm going to do is I'm going to substring between when I found the first part to where I am, plus one, because obviously I want to keep that that chevron as well. I think that's. I think that will affect it, but I'll still check. I think it was slightly wrong. Yeah, so it misses that last one off. I was right. So you see there my output. If I just run it again, that takes all of those out, which is good. Now the beauty of like using ChatGPT though is that once I'd programmed this and got it working, I put it through with the question, and it said, oh yeah, this is right now. That's correct. So that's good. But hopefully, maybe Amelia about the grade boundaries. I mean, I don't know. I mean, I don't know if you're on about this question, or if you're on about the two's component one, but it's similar what question you're on about, because I don't know, because I'm a bit ahead of what you see on the screen. But yeah, that's that one anyway for that question. Yeah. Where is it? So it's Teams. It is weird that I'm streaming a stream, because I'm just streaming from a tablet. So part of the program checks that the tags are well formed. Blah blah blah. Tags are removed the same order they were added. What data structure is structure A? So by I missed 6A off. Oh no, that's fine. I was right. So we had them in. The tags are removed the same order that they were added. So that is going to be first in, first out, which is a Q. We've got data structure B is given a closing tag and a corresponding opening tag. So opening tag is data structure B get head. Opening tag is head. Just seeing anything else weird. So what is data structure B? So I think we need to read that a little bit. But it's saying dot get. Okay, so it's a data structure. It's going to be either a linked list. Yeah, sorry, a linked list. Linked list, stack queue, or a hash table. If you think about programming, there's a lot of other ones as well. So I think with that one, I just banged my elbow. It's gonna be tag that should be clear to these corresponding pin tag. So you're searching for an actual value. So it's probably a dictionary. So a dictionary in most languages is you have like a key and a value. So if the value is if it's like two pairs, your key might be head and the value might be slash head, so you can see the start and end tags. So it's getting the key from the value, which is kind of dodgy. So it's probably going to be a dictionary. Now I've just looked at the mark scheme and they've said you can accept a dictionary, but they're saying hash table. So I think they're saying that maybe you'd have start key, end key, and then like a value for that. So as in you'd have like a table. So you've got 0, 1, 2, 3, let's say, and then you've got tag 1, tag 2, and you've got head, and then you've got slash head. So you just search for one of these and you'd get this, is what I'm getting. I assume they're getting that. I just had to scroll down the wrong thing. So then we've got check tags, which is something else. So we're looping through something. So loops while it's still valid, and it has tags. So whilst it's valid and it's not empty, you remove a tag and check the next tag. If tag substring is a slash, then if you remove it, it's not equal to get the tag. So dot remove. So that's weird, because that's this statement here, that remove is returning a value. because there's checking if it's not valid. So that's going to be a stack in it, because it's popping that from the stack. That is just a written version of a pop. And then Y is date structure C suited to check in if it's well formed, and then that's just going to be what is the stack, which is last in first out. I reckon that'll be. And then what we've got next. So complete the truth table for an XOR gate. So your XOR, so 1 1 0 0, because it's one or the other but not both. And then we've got these. Now I know, because I know from looking at it, from teaching it, but that is there's a half adder. You got a full adder there. Sorry, that's a half adder. That's a full adder together. So you just got to calculate that out. So S is going to be this goes 2 pages. That's awkward. So it's 1 0 0 1 0 1 1 0, and then you see out is the ands, which is going to be 1 1 1 0 1 0 0 0, and then what you should get is if you add 1 plus 1 plus 1. So if you add 1 1 1 in binary, it's going to be 1 with 1 on the step, 1 1 on the step, because that's your carry out, and your S, your sum. There's that one. So I mean, explain it. I know that it adds 3 binary numbers, or it's a full adder, but for 4 marks, what you're actually going to write. So they've said circuit adds 2 bits, and the carry bit is an adder, so you get marked for that. A, B, and C are added in together, and the result is S, and the carry is C. So just explaining what half adder does, full adder does. Ooh, an atrociously horrible question. This would be great. I hate these. Oh god, I can't actually see the bloody screen. One second, I'm just going to open it on my computer so I can see. So I can see the actual thing and actually look at my screen at the same time. What question is this? 7C. Sorry, I've just got to scroll up. Right, so what we're looking at. So it's S. So S is it's going to be A XOR B, because the first logic gate. Which is going to be XOR'd with C. So A XOR B XOR C would make sense. Yeah, so just, yeah, I don't think you need the brackets. So yeah, A XOR B XOR C, because obviously you do those together and then do that last. Or is it called C or is it C in? Because I don't want to get it wrong. Yeah, C in, sorry. So it's C in, not C. And then what is C out? So C out is a lot more complicated. I presume they want us to do the whole thing. They don't want to just put, yeah, so we have to look at, you can't see my mouse, can you? So we've got the A XOR B, so it's always going to have A XOR B, which is ANDed with C in. So and C seeing, which is an OR with, so OR, and that's A and B. I think that would be. I'm just going to check the math scheme. So they've said A XOR B, yep, and C in, or A and B. So yeah, that's right. That's cool. That's good. I like logic gates. Why am I doing that? I'm scrolling on my face to look at the maths, the questions, and they're here. So then we've got our database question. So it's saying, why can't we use any of these as primary key? So it's a music streaming service for this one. So we've got the streaming service and title. Well, we could have 2 songs with the same name, 2 artists with same name. We definitely will. So for this, there's going to need to be a composite key or just a nice primary key. So none are unique. Let me put an example here, e.g. 2 songs, same title, or 2 songs of the same artist. Anything really. Anyone else want to come in the stream? Nope, just you and me still, Amelia. That's good, isn't it? Okay. So this next question is indexing the field artist. Advantage or disadvantage. I don't even remember what indexing is, but it's the same as like a hash map or a hash table, where if you basically know where it is, you can search for it faster. Searching faster, but you have to save the separate index table, sort of like that, in memory. So takes up more space. So now we've got users can build up a playlist of songs. Another table is called playlist. Why a third table called playlist entry is needed. So you could probably have one song, or many different songs can be used in many different playlists. So it'd be a many to many, which you're not allowed. So you'd have playlist song, and then the entry. So that's terrible drawing. Because you can't just say, oh, I'm going to have one song in a playlist, because there's many songs in this database. So yeah, so that's why that playlist entry is in there. So so one playlist can have multiple playlist entries, and each playlist entry can have, or multiple playlist entries can have one song in it. That makes sense. So you've got multiple ones added into a database at a time, I think is what it's getting at. A band called Random Bits removes permission, so they have to remove it all. What's it going to be? Well, it's be copyright, so it's not going to be data protection because it's not talking about personal data. How can we delete that? So we don't do any stars, but delete from song, and then where artist equals that, which is random bits. And then referential integrity. I remember this question doing it in lessons. What you have to do is all the songs by random bits need to be removed. From playlist entry. I'll go with that one. Yeah, so that's that one. Your next one is looking at what do you need an operating system for. I don't like this question. I've seen it before, and they only give you one answer, and there's loads of reasons. You provide an interface, interface with peripherals, but they're going with if you ever get just a one marker, I think it just needs to be, because that's the fundamental thing. That's what our operating system's there for, but obviously it uses other things as well, which is annoying. So it's mobile phone. I remember doing this in our very first assessment. So how could you use virtual machines? So you can run the OS. So run OS whilst the real phone is being built. And then next one is a bit of a random scenario. So I'm just getting comfy. To stick an interrupt question in. I'm just going to move this a bit. So what we're going to do when you get an interrupt, so we need to finish, probably say current, finish the current FDE cycle, check the priority, if it's greater than the current task, let's say, push registers to a stack in RAM or in memory, load an interrupt service routine, when done pop stack. I think you get a mark. Let's just check. That gets you a mark. Loading in separate service routine gets you a mark. Oops. Push into a stack in memory gets 2 marks. 1, 2, 3, 4. Finish. Check priority. Technically we've got 7, but because I'd get a mark for that as well. But obviously there's only 6 marks in this question, so you won't. Not done this for a while, this stuff, so you might remember this stuff, but so obviously you've done your NEAs. It's very similar. Like there's a lot of bits to it, but think about what we did our NEA. What were 3 stages we did? We didn't do it as waterfall. We did it as agile, but the stages are the same. So we did analysis, we did design, we did evaluation, we did testing, we did implementation. We could also so we've got test, eval. There's even like deployment, maintenance, things like that as well. So why is waterfall suited to the operating system? So we do waterfall is for static, maybe is a good word. So static requirements. So what I mean by that is where your requirements aren't going to change. Like the whole point of waterfall is that you sort of, the first part of the mark scheme I don't like. It tends to suit large scale projects. I thought it was for smaller projects because you don't give them to the users as much. The whole point of your agile one is that each cycle you spoke to your clients, you spoke to your you spoke to your stakeholders and asked them, is this alright? Do you need to change anything? And then carried on again, had loads of rapid prototyping. Whereas waterfall, you just do it all sort of in one big go, and you don't not often see anything until it's finished. So you definitely get a mark for that one. So I suppose set requirements and the OS, you probably wouldn't change your mind too much, maybe. I think I agree with the mark scheme on that one. But disadvantage to the waterfall cycle, if there's a change, really, you start the cycle again, and that costs money or costs time. I'll put money in time. So that's that one. And then we've done this one before. Is it the last question? No, there's loads more. So this one we've got to talk about encapsulation, polymorphism, all those bits. So again, your knowledge dump, you have to explain what are these three things. Then you would say, so you've got AO1, which would be that, AO. Then you've got AO2, so what's good and what's bad. So your advantages and disadvantages. And then your last bit would be your evaluation, where you'd be saying why is it better than procedural. So you can talk about having a class that's going to you use multiple times, so you don't have to keep reusing code, all that kind of stuff. What's to add? An image. So we've got image source equals UK stamps.jpg. That's that one. Oh. I'm sorry, I'm yawning, I'm tired now. What should go in B? So I do remember giving this to you guys as Fetch as well. That is the string, not the whole thing, which is a hyperlink. So href equals that URL. I'm going to be lazy because I can be. And then you could put a P in there, but you don't need to. You can just put find out more about UK stamps. Slash A. Sorry, I'm yawning. So the site uses. Sorry, I was checking the chat. The site uses style links out as attributes and tags rather than a linked CSS file. So they're doing things like body BG color. What's the disadvantage? Well, every tag will need the formatting written. So you're changing anything, so changes need rewriting every page. Disadvantage to the site's visitors, it'll be slower. I'll put slower to load. What changes we need? So we've got the site needs a light green background. What changes to the current page? I mean, how would I do it? This one, I mean, technically you should do it properly, but I suppose if they've already said that they have done it in line, so it's going to be body BG color equals light green. And the site owner notices that his site doesn't come up high. What affects his page rank? So that is outbound links. So number of outbound links, and the number of sites that link to his site. I presume there's a man there. That's sexist, I'm afraid. Sorry. Yeah, so that's that done. That's the paper. I can send you a smart scheme if you need, Amelia. So it's 8:30 now. is there anything, because I'm probably going to go in a bit, but I don't mind doing one last thing. Is there any topic you'd want me to find a question for and do before I go? Yep, just put some bits together, Amelia. And then, like I said, between 9 and 10, I've got a lesson, but from 10 o'clock, I've got nothing. Obviously, you can come and sit at the back, but obviously, I can't leave my class to help you until they're gone. All right. Yes, literally from 10:20, we're free, all the way till your exam. All right. Hopefully, that was all right. Yeah. Cheers. Thank you. I'll try to. Probably a chilled one from me. Not doing that whole 10k rubbish. Yeah. Well, hopefully, I think this automatically turns it into a video anyway, so the others can see it. But yeah, I shall see you on Monday then.